Hi guys, welcome to a lesson of partial differential equation. Now in this class, we are going to discuss the non-homogeneous wave equation with time-dependent Newman boundary conditions and time-dependent sources, right? So here an equation is given that is utt minus 4uxx that is equals to 1 minus x times cosine t, and the boundary conditions are given as the non-homogeneous time-dependent Newman boundary conditions where ux0t is equals to cosine t minus 1 and ux pi t is equals to cosine t, and the initial conditions are given as well, that is ux0 is equals to x squared over 2 pi and utx comma 0 is equals to cosine 3x. All right, so now in order to solve this problem, first of all, we know that for these types of problems we generally have two solutions, and then by using the principle of superposition we get the particular solution for the problem. Therefore we will split the problem into two parts. So uxt is equals to wxt plus vxt, where vxt is given by x times a of t plus x squared over 2l times b of t minus a of t, right? So here b of t and a of t are the boundary conditions. So a of t is given as cosine t minus 1 and b of t is given as cosine t. So these are the boundary conditions. Therefore, we are going to apply the boundary conditions to this equation. So now vxt is equals to x times cosine t minus 1 plus x squared over 2l. That is pi in this case. L is equals to pi. Therefore, here it will be 2 pi. All right, so x squared over 2 pi times cosine t minus cosine t plus 1. All right, so cosine cancels, and now we will left with this equation, that is v of xt is equals to x cosine t minus x plus x squared over 2 pi. So here we can see that vtt will be equals to negative x times cosine t, and vxx will be equals to 1 over pi. All right, from here we can find vtt vxx, and so this is vtt and this is vxx. Now wxt will be equals to uxt minus vxt. Therefore wtt minus 4wxx is equals to utt minus 4uxx minus vtt minus 4vxx. So we will plug the values. Ut minus 4uxx is given as cosine t minus x cosine t, then negative sign times this function vtt minus 4vxx here. So these terms will cancel out, and finally we will have wtt is equals to negative 4wxx is equals to cosine t plus 4 over pi. All right, so this is plus sign, and now the boundary conditions will be homogeneous, and the initial conditions will be transformed as well. So w of x comma 0 will be equals to u of x comma 0 minus v of x comma 0, right? So u of x comma 0 minus v of x comma 0. So x squared over 2 pi is u of x comma 0, and then v of x comma 0 is also x over 2 pi. Therefore, we have this condition is equals to 0. All right, and then the initial condition will also be wt of x comma 0 will be equals to ut of x comma 0 minus vt of x comma 0. All right, so from this equation we will get this initial value, this initial velocity for the problem. Now we can solve this problem by further splitting this problem into two parts, because we have this non-homogeneous time-dependent source here, and we have homogeneous Newman boundary conditions. So we can split this problem by the phenomena that the one problem will take the conditions, initial conditions, and other problem will take the non-homogeneous part with the homogeneous boundary and initial conditions, right? So here we can solve this equation. We know how to solve it. This is Newman problem, Newman boundary conditions, homogeneous equation. So the solution is given by S of xt is equals to AT plus B plus summation an cosine nx cosine 2nt plus summation bn cosine nx sine 2nt, right? Now we will formulate an and bn, these coefficients. So here the initial condition is 0 and here it's 3x. So first of all, we will use this condition as x of 0. From here we can get b and a and 0. And then we can use the second condition. So the second condition implies that the derivative of s will be a plus, say, summation 2n bn cosine and x times cosine and 2n pi t. Therefore, at t is equals to 0, this will be equal to this, right? So it's equals to cosine 3x, and a is equals to 0 because no constant on the right hand side. And we can also formulate it by using the Fourier series, Fourier cosine series. So a will be equals to 2 over pi 0 to pi cosine 3x. And we know that the value of this integral will be equals to 0 because the integral will be sine 3x, and sine pi is also 0, sine 0 is 0. Therefore, a is 0, and for bn, we know that we can compare this with this coefficient, and we only have 3x here, therefore we will get b3 only, right? So by comparing the coefficient, we can get the p3, that is 1 over 6. So finally, the solution for sxt is 1 over 6 times cosine 3x times sine 6t, right? So this is sxt. Now we will find zxt. For zxt, we can use the method of Eigen function expansion or the method of Laplace transform. So it's feasible here to use the method of Laplace transform because we have homogeneous Newman boundary conditions, and we don't have any function of x on the right hand side. Therefore, it's feasible to solve this using Laplace transform. So we'll apply the Laplace transforms on the equation both on the left and right hand sides. So now this is a second order non-homogeneous differential equation. So therefore, the solution to this problem will be U homogeneous plus U particular. So U homogeneous will be 0 because we have Newman boundary conditions and they are homogeneous. Therefore, C1, C2 will be 0. So UH is equals to 0, right? And then to formulate UP, we will use the operator D method. We will operate with this D, and we will get this function that is 1 over, from here we can see that this will be, we can transfer this to the numerator, d square minus s square over 4 with negative power 1 sign. And then we will multiply it by this whole function, right? So the derivative of this function will be 0. We'll expand this by using the binomial theorem. So we will only get 1 times this function, and all other derivatives will be 0. All right, so finally we're left with 1 over s times s squared plus 1 plus 4 over pi s cubed. And then we will apply the inverse transform to find the function in terms of zx comma t. So this is our zx comma t. Now we can sum up all the equations, that is s of x comma t, z of x comma t, and v of x comma t. So we will get the particular solution for this problem. That is u of x comma t is equals to x cosine t minus 1 plus x square over 2 pi. That was our v of x comma t, and this whole is our wx comma t. All right, so in this way we can solve the problems. You can see that we have used multiple methods for this problem. And now we'll move to another problem, another example. We have, again, we have a time dependent source on the right hand side. So, and the conditions are homogeneous boundary conditions. So this is a bit simpler problem, but we will use some other methods for this problem. So again, we can split the problem. Here uxt is equals to wxt plus vxt, and then the problem, we can see that one problem will take the initial conditions and the other problem will take the heat source, right, with the homogeneous conditions. So for this equation, static, we named it as static. So for static, we know that the solution will be, this will be the general solution, an sine n pi x times cosine n pi t plus this summation. So from here we can apply the initial conditions to find an and bn. Therefore wt is equals to 0, so we'll get bn is equals to 0. All right, and now we can work out for an. We will use the cosines, we'll use the Fourier sine series. We will formulate the integral, apply the limits, and here we can see that this is the Fourier integral, and we solve the integral, apply the limits from 0 to 1. Here we solve the integral, and at last here we applied the limits, and we get this function 8 over n cube pi cube for all n is equals to odd, and 0 for all n is equals to even numbers, right? So we can now put n is equals to 2n minus 1 because we are dealing with odd numbers only. So for every n we will put 2n minus 1. Therefore we will get wxt is equals to this function. Now we will work for v of x t. For v of x t, we have this heat source, but now this is with the product of x, and the boundary conditions are the homogeneous Dirichlet boundary conditions. And again, the initial conditions are 0, so we can't use Laplace transforms here because it will be more complicated to solve with Laplace transform. Therefore, we are using the method of eigenfunction expansion. So we can expand the eigenfunction for this problem. These boundary conditions will be sine n pi x. So the solution vxt can be written as summation n is equals to 1 to infinity an of t times the eigenfunction, that is sine n pi x, right? So we have to formulate a and t in this problem. Therefore, this is a second order, this is a wave equation. So we have a second partial derivative of time t. In the case of heat equation, we have first partial derivative of t. Therefore, we use a n prime plus n square pi square a n. But here we will use a n double prime because we have second derivative of time, right? So a n double prime plus n squared pi squared a n is equals to 2 sine t times the integral of this is fxt. Fxt in this case is equals to x sine t. So we already discussed how to formulate this this equation, so in the previous classes, and now we are doing it directly. So 2 sine t times the integral of s sine n pi x dx from 0 to 1. Therefore, this will be a n double prime plus n squared pi squared a n 2 sine t times this function. So the integral of this function is equals to this. And for the conditions, initial conditions, we have both conditions 0, 0. Therefore, a n 0 will also be equals to 0, and n prime will be equals to 0. So now we can solve this equation. This is a second order non-homogeneous differential equation. So we can use the auxiliary equation for a n homogeneous part and particular solution by operator D method, right? So here the homogeneous part will be a cosine n pi t plus b sine n pi t, and the particular solution we can get by applying the operator D method, right? So we all are familiar with the operator D method. We'll operate this here it is sine t. Therefore, we will put here -1 squared, so it will be 2 sine t times -1 n plus 1 over n pi over -1 plus n square pi square, but we write in this way, right, to make it more simpler, and then we will get this function. Now we have the solution. An is equals to an homogeneous and an particular, right? So now we'll apply the conditions, initial conditions, that is an of 0 is equals to 0 and a prime n of 0 is also equals to 0. So an of 0 implies that a is equals to 0, and n prime of 0 implies that this is n pi b cosine 0 plus 2 times -1 over -1 power n plus 1 cosine 0 over n pi times n squared pi squared 1, that is equals to 0. So from here we can get b. All right, so this is 1 cosine 0 and this is also 1 cosine 0. Therefore you left with n pi b is equals to negative times this function, right? So we can take this n pi to the denominator on the right hand side. Therefore we will get this function b. Right now we can replace b in the original equation that was for an. Here we replace the function b, so this function is b. All right, so it was b times sine n pi t, so this is b, then plus 2 times -1 over a power n plus 1 sine t over the denominator here, right? So now we can write v of xt in the form of summation, because we already said that it's equals to summation an sine n pi x, right? So an we found here from n is equals to 1 to infinity. Now we can plug in this whole is the an times the eigen function. So now the general solution, particular solution, will be given by uxt is equals to vxt plus wxt. Vxt, wxt in our problem is this function, and vxt in the problem is this function. Therefore, by using the superposition principle, we can sum up the solutions and we will get the particular solution for the problem. Now we can verify the boundary conditions here. V0t is equals to 0. Therefore, if we put 0 here, it will be 0. Again, 0 here will be 0. So this is 0 verified, right? V1 comma t, if we put 1 here for x, so it will be 0. Sine 2n minus 1 pi is 0. And again, sine n pi is 0. So again, it will be 0, right? And wx comma 0 will be equals to, if we put 0 here in this part, so we will get 1. Therefore, we will left with this part only, right? And for here, if here we put 0 sine t, it will become 0, and this will also become 0. Therefore, this whole will become 0, right? So we're left with only this part, this one. So this part is equals to the basically x times 1 minus x, because we calculated the Fourier series of this function that was equals to this function, right? So this is verified as well. Therefore, now vtx comma 0. For vtx comma 0, if we differentiate this, this will be sine 2n minus 1 pi t. So at t is equals to 0, this whole will be 0. And for this here, it will be sine t will be cosine t. Here you can see that cosine t over n pi, and this will be n pi times cosine n pi t, right? So n pi will cancel with 1 n pi here, so we're left with n pi in the denominator. Therefore, if we put t is equals to 0, so this will be cos 0, so it's 1. So 1 over n pi minus 1 over n pi is 0. And therefore, this whole will be 0. This whole will become 0. So vt of x comma 0 is also equals to 0, right? So the conditions are verified. Sorry, this is not v, this is u. By mistake, it's written v here. So these all are u, right? Because now we are working for particular solution of u. So it's u. So the conditions are satisfied. for the equation, for the solution of the equation. So in this way, we can formulate the problems, we can solve the problems, we have methods to solve these problems. So in these two problems, we use the Laplace transforms as well, separation of variables as well. We use the method of eigenfunction expansion. So hope you guys will learn from this lesson. That's all for the time being. Thank you and goodbye.